Hi everyone, Jassy here, and it's my pleasure to introduce you today to the Grapple Robotics LaserCAN. It's our first FRC product, which we'll be shipping for 2024 kickoff. It's a laser ranging sensor with a range of up to 4 meters, depending on ambient light conditions. It's addressable over the CAN bus and is absolutely tiny, only 25 by 25 millimeters. Now, this thing has a range of use cases. You can use it to detect a game piece. You can use it to detect other robots getting in your robot's personal space. Or you can use it to detect heights of elevators without having to deal with encoders. Now, if I go ahead and pull over my little demo here, you can see that I've got a robo rear with 2 LaserCAN sensors on it. Now, we're powering these straight off the robo rear, but you don't have to. You can power them off of a power distribution panel or power distribution hub. They're wired in directly into the CAN bus, and you can see here we've got a little termination resistor since we don't have a power distribution panel to terminate on. And if I go ahead and bring up its companion software application right here, Grapple Hook, you can see that we have 2 sensors showing up. Now, what I can do is I can blink each of these sensors to detect which one's which. So as you can see, that's the one on the bottom of the frame. This is the one on the top of the frame. I can change their IDs, I can change their names to something more friendly, like intake sensor, for example. I can do firmware updates, I can commit their configuration, but really the most important stuff is right down here. The ranging mode, timing budget, region of interest, and our current readouts for both distance and ambient light level. So, in its most basic form, you can see that when I move my hand around, we are getting laser measurements. Now I can change the ranging mode here from short to long, in which case you can see it starts detecting my ceiling. Long has a longer ranging distance, however, it is more susceptible to ambient light, which is why we try to keep it on short most of the time, which has a range of up to about 1.3 meters. Our timing budget gives us a way to determine how quickly we want to get updates out of the sensor at the cost of accuracy. So less often measurements, so say 10 Hertz, will give you more accurate measurements than 50 Hertz. But you can adjust it right from here. We've also got the coolest part, in my opinion, the region of interest. So you can see here that we have a 16 by 16 array of small sensors on board this sensor. So if you want a wide field of view, you can select all of them, and you can see they will detect my hand even when I'm slightly off the sensor, and generally lets in a lot more light. However, if I'm using this on an elevator, for example, I probably want to reduce that field of view to just what's necessary to reduce the amount of ambient light coming in, reduce occlusions from other objects nearby, and just get the height from that sensor. Now, these don't have to be on center. They can actually be off-center as well. So if you want to detect something to the flanks of the sensor, you can do that too. Maybe you want to ignore a little region which has, say, a piece of aluminum extrusion. But this is completely configurable, and you can do this from robot code. Now, getting started in robot code is super simple. It only takes a couple of lines, and our vendor libraries are very easy to use in both C++ and Java to get your sensor working as soon as possible. If this sounds good to you and you'd love to pick one up, head over to grapplerobotics.au.